Hi, in this video, we're going to be trying to determine all of the values where a function is either increasing or decreasing. Now, it's not a big surprise that if our derivative is positive, then our function is increasing on some interval. If our derivative is negative, that means our original function is decreasing on that interval. But where is it moving from this increasing to decreasing? Well, that's what critical values are talking about. There are locations, just the x part of a location, where the derivative equals zero or is undefined. Whenever that happens, the derivative has to make a choice whether it's going to be positive or negative after that point. So that's where it might change its mind from what it was before that point where it was either zero or undefined. So in this example, I've got a function and I want to know the open intervals where the function is increasing or decreasing. By open intervals, they're saying don't put brackets on this thing. So if we look right here, it is going down. So it is decreasing from negative infinity to looks like about 3. And then about here, it seems to be turning around and changing its mind and start increasing. So that's just kind of my estimate looking at the graph. What about if we use derivative stuff? So I found my derivative of this. I first want to find that critical value. When does this thing equal 0? Well, f prime of x equals 0 whenever that 2x minus 6 equals 0. Well, that'll be at x equals 3. So then what I do is I come over here and I do just a simple number line. And I put 3 on that number line. And on that number line, I'm going to be figuring out what is going on with f prime, as well as what's going on with my original function. So if I put some number into the derivative that is bigger than 3, let's say a million, then 2 times a million, that's going to be pretty big, minus 6, that's going to be positive. So f prime is going to be positive over here. If I put like a million into this, I would also get something that is positive into the original function. Next, what if I put something that is less than 3? I'm going to use something simple. I'm not going to do negative a million. I'm just going to do 0 because that's a really easy thing to plug in. If I plug in a 0 right there, I get 0 minus 6. So I get a negative value from the derivative. And then if I plug 0 into here, I also get a positive value at 0, so that is positive. So on either side of 3, f prime is negative and then positive. Since f prime is negative, it is decreasing here. And if I check a value that is bigger than 3, I get a positive. So that means that the original function is increasing. The value of the derivative is positive. So the original function is increasing and the value of the derivative is negative. So the original function is decreasing. And I've written all that down right here. Look at it. Look at it with your eyes. So this is finding that same thing. I estimated it with the graph, but we could figure it out just by looking at the derivative, which can be easier than graphing some of these things. In this example, we've got more things going on with our function, but we can see that we are increasing like here and there. So that's what I'm trying to show up there. And then there are a couple intervals where we're decreasing. So we're kind of heading down there and there. Well, I can tell that based on the graph, but can I tell that based on derivatives? Well, I found the derivative already. And then I want to see what is the critical values. Where could this thing change its mind? Where does it equal 0 or undefined? So f prime of x equals 0 when x equals 0, when x equals 1, and when x equals negative 1. So I've got multiple things on my sign chart that I'm going to have to be checking. So I need negative 1, I need 0, and I need 1. And whenever I put these numbers on here, I usually try to just space them out so that I can see what's going on in between them and have enough space to write. So I am going to start with something that is really deep in the negatives. So if I do something right here that's really deep in the negatives, mostly I just care about what is the signs of these things so I can figure out what the sign of the derivative is. I don't care what the actual value is. I just care what the sign of that value is going to be. If I put that negative value right here, I get some negative thing. And then a negative minus another negative, that thing's going to be negative 2, and then that will also be negative. So three negatives multiplied together means that f prime is going to be negative when we're less than negative 1. And if f prime is negative, that means our original function is decreasing. If we check something between negative 1 and 0, like negative a half, this will be positive, negative a half plus 1. That'll still be positive. This will be negative. That'll be negative. So overall, a negative times a positive, that is going to be positive. And since the derivative is positive, our original function is increasing. Next, we can check some number between 0 and 1. So a half. So this will be positive, this will be negative, and this will be positive. Multiply all those together, we get a negative on our derivative. So our original function is decreasing. We can do that one more time. I'm running out of colors. With numbers that are bigger than 1, huge positive number, that's positive. Huge positive number, minus 1, that's still going to be positive. And then another positive. So overall, we are going to be positive here. Oh no, now that's another color. And then this is increasing. And that matches up with what we got in our estimate. And then we can write a sentence. Here it is. I already had written it. So f increases on negative 1 to 0 and 1 to infinity. So negative 1 to 0 and 1 to infinity. Note that I'm using open intervals because that's what they asked me to do. And f of x decreases from negative infinity to negative 1 and 0 to 1. Huzzah! Enough of this graphing stuff. Can't we just figure it out based on the derivative? Yeah, of course. Watch how easy it is. I've got this function here, and I found its derivative. Now I just need to figure out when that derivative equals 0 or is undefined. It is defined everywhere, but g prime of x will equal 0 when x equals 1. So that is what we're going to use as our critical value to divvy up our number line. And then we need to see what g prime of x is on either side of 1. If I plug in some number that is bigger than 1, then I'm going to get like some big positive value right here, minus 2. That's still going to be a positive value. So this will be positive, and g of x will be increasing since the derivative is positive. If we plug in some number, I'm going to do 0 because that's easy. If I plug in 0 right here, 0 minus 2 is going to be negative 2. My light is gone. And since that is negative, then this is going to be decreasing. So those are the two intervals. It's decreasing where the derivative is negative, and positive where it's going to be increasing. There, that was a terrible sentence, but that's what I was trying to say. That is it for our video on increasing and decreasing. It's that simple. It's just figuring out when the derivative is going to be positive or negative. Just use those critical values where the derivative equals 0, or if the derivative is undefined, use those to divvy up your number line, and then just check, is the derivative positive or negative on either side of all of those critical values where the derivative is equal to 0 or undefined. Thanks for watching. I hope you took some good notes. You got some good number lines, and I'll catch you next time. Goodbye.